All right, welcome back everybody. This is episode 4 of my Elisity Cognitive Trust series, and in this episode, we're going to be showing you an OT device and user security demo. Taylor, my technical marketing engineer, is back, and he's going to be doing the demo for us. But before we jump into the demo, I want to quickly touch on the identity engine that we built here at Elisity. From the beginning, Elisity has been focused on bringing to the market a solution that's completely brownfield ready and non-disruptive. That includes the robust identity engine as well as the comprehensive policy enforcement component of our platform. The identity engine allows us to dynamically discover devices, users, and applications on a network. And it doesn't matter what type of network you're on. It could be an operational technologies environment like we're talking about today. It could be a medical environment, a process control network. It could be your standard carpeted space corporate network. It really doesn't matter. It also doesn't matter what type of devices, users, and applications you're running on the network. Elisity is completely network agnostic. We run on top of your existing environment, and that's what allows us to be completely non-disruptive. We are not in the data plane. Rather, we are a control and policy plane that incorporates passive identity. We don't make any changes to the access ports. We're not playing with MAC authentication bypass. We're not adjusting 802.1x configurations. There's no user agents or supplicant requirements, and we're independent of the VLANs and VRFs and network topology or physical architecture that you're already using. We don't manipulate any of that. So this allows us to be 100% non-disruptive. And I love that because it makes it so easy to integrate into any type of network. We can deploy our solution and reach the time to value extremely rapidly. Now, while Elicity's device identification engine is great and can be completely standalone, we also integrate with third-party industry-specific identification engines and CMDBs such as Claroty, Dragos, Metagate, ServiceNow, Tenable, and many others using simple API-based connectors. This allows us to enrich our asset inventory and get a bigger and fuller picture of what's out there on the network. For the purpose of this demo, we'll be focusing on the Claroty connector example. So the next set of slides, I'm going to jump into our Claroty integration at a high level. Here's how the integration works. At the cloud layer, we have Elisity Cloud Control Center. This is our cloud delivered and cloud native control plane, management plane, and policy plane. On-prem, Elisity has deployed Elisity software running as a container on switches that support application hosting such as the Catalyst 9000, or as a virtual appliance deployed on any type of hypervisor anywhere in your network to onboard switches that don't support application hosting. The Elisity software is collecting identity metadata and also translating policy to be enforced at the access layer. From the Claroty perspective, there's a collection server that's collecting flows for the purposes of identifying in depth all the OT devices on the network. Claroty also supports an enterprise management console that can aggregate all the data from many independent collectors. Let's run through this step by step. When a device shows up on the network, both Elisity and Claroty are simultaneously doing the identification process. Elisity is collecting metadata about the device and sending it up to the Cloud Control Center. Claroty is also doing the same thing with their collection server and optionally sending it to EMC, Enterprise Management Console. Once this analysis is complete, Cloud Control Center will query the Claroty collector or Enterprise Management Console via an API connection to enrich our asset inventory with additional attributes that Claroty learned. Now, it's as simple as the system doing a match between the devices that were learned and the policies that you created, and then pushing those policies to the edge of the network to be enforced immediately. It's really as simple as that. So I'm going to hand it over to Taylor to actually show a real-world demo of this.
Thanks, Dana. So like you said, for this demo, we are using our connector with Claroty to enrich our inventory of operational technology devices. So here we can see our active connector to Claroty. And if we move over to our inventory of OT devices, here we can see several devices that we've discovered, of which we've gleaned additional information through our connector with Claroty. Let's look at this temperature and humidity sensor. Here we can see all of the identifying data that we've learned about this device, like device vendor, class, and model. We can see the policy enforcement node that this device is located behind. And we can see that the device is discovered by industrial protocol because we've identified Modbus traffic from this device, which is a common protocol in OT environments, and therefore identified this as an industrial device. All of this data can be used to match this device to a policy group. Actually, this device is already associated with a policy group based on its identity as a Modbus sensor, and it has a set of policies. We can do the same thing with users here. Let's go over to our user dashboard and look at our user Olivia Douglas. Olivia is a member of the AD group operators, and we can see her policy group operators is based on her identity in that Active Directory group. And she also has a set of policies based on her identity. Let's move over to the graphical policy visualization matrix and take a look at a few of these policies. First, let's look at our user policies. We have Olivia, she's an operator, so let's search for operators in the policy matrix. Here we can see the set of policies that apply to our policy group operators. In particular, we're blocking traffic to most of the other devices and users on the network, like printers and media servers. We're blocking user-to-user traffic between operators and contractors here. And we're specifically allowing SSH traffic to one of our PLC controllers, and we're allowing all traffic to our Modbus sensor. This set of policies for the operators policy group was designed to give operators least privilege access, only access to the things that they need to do their job in this industrial network. Let's look at some device-to-device policies in the policy matrix as well. So we have our PLC controllers and we have our Modbus sensors. Let's look at our set of policies for PLC controllers on the network. So we'll search PLC, and we can see our policy group PLC controllers. I want to focus on this PLC controllers to Modbus sensors policy. If we click on this, here we can see the source and destination and what we're matching on for each of those. And if we look at the security profile rules, we can see we're allowing Modbus traffic and denying all other traffic. We only want PLC controllers to be able to communicate with Modbus sensors via Modbus traffic and nothing else. Let's go back to the policy matrix and look at our users policy. So Olivia is an operator, so let's go ahead and search for operators on our policy matrix. So here we can see the set of policies for the operators policy group. And we can see we're denying most traffic to IoT devices and IT devices like printers and media servers. However, we're allowing access to PLC controllers and Modbus sensors. Let's see what these policies look like from our user's perspective. So we'll jump over to our user's personal computer. Here we are on Olivia's PC. Olivia, again, is a member of the operators AD group, and she has the set of policies that we looked at earlier. So here we can see her network access reflects those policies. She's denied access to the printers. She's denied access to IT and IoT devices. However, we're allowing her access to the temperature and humidity sensor and to the PLC controller. Let's go ahead and utilize the access that these policies are giving us to jump on these devices and demonstrate some device-to-device policy. So we have a secure shell session started to the PLC controller, the PLC polling server. Our policy also gives us the ability to utilize remote desktop connections to our Modbus sensor. So let's begin a session there. So here we are on our simulated temperature and humidity sensor. Now what I want to do is run a query from the PLC polling server, or the PLC controller, to this Modbus sensor. And I want to return these values over Modbus protocol. So let's view the values and make sure that these match what we're returning from our query. So here we can see we have a number of temperatures. We have freezing, boiling, and then randomly 5 temperatures. We can see that this is ready to receive queries, it's running. Let's move back over to the SSH session that we have running on the PLC controller. Now I'm going to run a Modbus query here. We're going to pull 7 values from our simulated sensor. So let's run this query and see what we get. Boom, we have those values and we've retrieved these over Modbus protocol. Now let's change the policy to block Modbus traffic between these two devices. So we'll go back over to our policy matrix. We'll search PLC controllers again, and we'll find our PLC to Modbus sensors. Let's select this policy, and where it says allow Modbus traffic, we'll switch allow to deny. We'll deploy this policy, and within 5 seconds, this policy is pushed to our policy enforcement node, and this traffic will be blocked. So I'll wait a couple seconds here, and then I'll run another query.
So in this case, Taylor, the policy enforcement node is any access switch that we support at the edge of the network where the polling server or Modbus sensor is connected, right?
That's right, exactly. So here we can see Modbus traffic is being blocked between these two devices within a matter of seconds.
Yeah, this is pretty cool because you didn't have to specify any IP addresses, any MACs, any VLANs, or VRFs, no network constructs. This allows us to completely decouple identity from any network construct. All you did was match on attributes of those PLC controllers or Modbus devices. In this case, maybe you matched on vendor, model, or device type, and that was enough for the system to pick up the identity of that device and then enforce this least privileged access policy that you created. So now these devices can only talk to each other on the ports and protocols that they were designed to talk on, so that they can never be used as hop-off points for bad actors or exploited in any other way. It's only being used for its intended purposes.
Exactly. It's just another way to segment your network without those traditional constructs like VLANs and firewalls.
Yeah, it's much simpler.
So the other piece to this is securing user access to these devices within this OT environment. So if we actually move over to Active Directory and we find our user within Active Directory, let's go ahead and change our user's Active Directory group membership. And we'll change her from operators to production managers in this case. So, production managers have no need to access these OT devices like the PLC polling servers and, these temperature and humidity sensors. Let's go ahead and change her identity now. So as I apply this identity change, within seconds, our user's access on the network is going to dramatically change. So we can see now we have access to all the IT and IoT devices on the network, but we've lost access to both the temperature and humidity sensor and the PLC controller.
Brilliant. That was pretty much immediate. It's amazing that we're able to detect the change and apply policy to the edge within seconds across your entire enterprise.
And not only that, these sessions, this remote desktop session was cut off mid-session. We don't have to log out and log back in for this to take place. Similarly, with the SSH session, we have no connection now to the PLC polling server.
Yeah, immediate cutoff. There's no new session creation required. It's just an instantaneous action.
Yeah, you could apply this to offboarding users as well. There's so many ways to leverage these capabilities.
Awesome work, Taylor. This demo truly showcased how simple Elisity has made it to implement least privileged access architectures and identity-based microsegmentation policies across your entire infrastructure edge.